All right, 6-2, inverse functions and relations. It's another lesson where you learn a couple of new processes, a couple different concepts. What you actually do, though, nothing new. Okay, it's all algebra, it's all solving equations, it's simplifying, plugging in, stuff like that. So the concepts are kind of new, but what you actually go do, nothing new. All right, everybody good? Going once, twice, everybody. Okay. All right, there's a lot up there. Okay, you really don't need any of it. It's more so for me to explain what we're going to end up doing. Okay, we're going to find inverses. Okay, so think about what, like, if I go invert something, what am I doing? Like real life stuff. If I go invert, everybody know what invert means? Opposite. Okay. Another way to think about it is I'm basically undoing what I've done. Okay, if I go do something and then I go invert that, like, I go work out, okay, and then I go home and eat a cheeseburger. I'm undoing what I've already done. Okay, that's basically what inverting means. Take that to inverses, take that to mathematics. What you plug in, you invert it and undo it and get that same number back. Okay, so that's basically what this says. Now, you're talking about this with sets of numbers. Okay, because these are going to be functions. So your first box here is talking about it as ordered pairs. Okay, so basically if these two are inverses of each other, in A, you would have the set 1, 5, 2, 6, 3, 7. And then in B, you'd have the set 5, 1, 6, 2, 7, 3. You invert the numbers. Okay, if they're given to you as a set of ordered pairs. All right. If you go down and talk to them actually as functions themselves, there'll be two different functions that undo one another. For example, let's say you have the function x minus 4. Okay, and they pick the number 6. So they put in 6 minus 4 and they get 2. Then they turn around and take 2 and plug it into the function x plus 4. Well, 2 plus 4 is 6. You're back to where you started. You undo this subtraction over here with this addition. So the two functions that are right there, they're considered inverses of one another. Okay? Hopefully that one obvious, right? X minus 4, x plus 4 logically would make sense. We're going to do ones where it may not be so obvious as to what it is. Okay? Any questions? Okay, the first one, just quick one, just make sure we're good with it. Find the inverse of the following set of points. All right, so you have 2, 3, negative 4, 8, 1, negative 3, 5, negative 5. In order to find that inverse, you take each pair of points and you flip them. X's for Y's. Okay. So 3, 2, negative 4, negative 3, 1, 5, 5. It took me years how to learn to write brackets or braces like that. Okay, so if yours are ugly, don't worry about it, but they do need to be there. Okay, they do need to be there. This slide starts where we're actually going to be given a function, and this is what we're going to do for the most part. All right, I'm going to give you a function, and you're going to tell me what its inverse is. And it's essentially done in 4 steps. Okay, the first step, you write the equation with x and y, because the function is going to be given to you as f of x. So you go and change f of x to y, just so that you have one variable instead of 2 letters and a set of parentheses, just to make it easier on yourself. Okay? That's step 1. Just rewrite it as that. Step 2 is going to be exchange x and y. Literally rewrite the equation with y in x's old spot and x in y's old spot. No sign changing, no magical algebra stuff. You literally rewrite it, exchanging the 2's places. Once you do that, you do whatever it takes to solve for y now. Whatever algebra you got to do to solve for y, that's what you do next. And then the last step, you rewrite it into function notation. That's clever.
You solve for y in both equations?
You solve for, it's going to be a process. So you're going to rewrite it as x and y, then you're going to flip x and y, and then once you get to step 2, you're going to solve for that y. It's one process, yeah. Okay? Now start off with an easy one. We got f of x equals 2x minus 5. Find its inverse. Step 1, rewrite as x and y. So y, f of x is fancy talk for y, so that's what you switch. So y equals 2x minus 5. Step 2, exchange x and y. You just rewrite it and flip where x and y are. That's it, nothing else. So x equals 2y minus 5. The 2 doesn't go with. Okay, that's the weird part. That's the non-algebra point of your brain that's got to take over and be like, just switch the 2. Okay? Now see, every time that's going to happen, x is going to be over here by itself. And y is going to be in with your clutter. So now you have to declutter this right side and solve for y. Okay? Can be 2 steps, can be 4 steps, usually not more than 4. All right, one of the complicated ones. This one's real easy. Just add 5 to both sides and divide by 2. So x plus 5 equals 2y. And then 1/2 x, everybody good with that? Plus 5 halves equals y. You could do that too. Either you can split it up, you can keep it as one fraction, totally up to you guys. Okay. Now, step 4 says what? On your little chart that you wrote down, hopefully. Rewrite in function notation. Now, remember about when we did yesterday with the f and g and h's, right? The nice part is that you have different letters to represent different different functions. Okay? So when we rewrite this, we're still going to rewrite it as f of x. Okay? Rewrite it as f of x. The only difference is we're going to add on a little special notation, and that's going to be basically a negative first power on it. And in function notation, that signifies the inverse. So here's your function, and then here's that guy's inverse. You need this -1 exponent, okay, in order to show it correct, get full credit. And then just rewrite the left-hand side. So 1/2 x plus 5 halves. Not today, though. Okay. So rewrite. So y equals x squared plus 1. Change x and y, so x equals y squared plus 1. Subtract the 1. So x minus 1 equals y squared. And how do you undo a squaring? Square root, good. Okay, square root. So you square root both sides. Okay, so you square root x minus 1. So the square root, let me go back to green, of x minus 1 equals just y. Rewrite into function notation, f -1 of x equals the square root of x minus 1. In order to verify if 2 functions are inverses, okay, so this type of problem, I'm going to give you 2 functions, okay? And to verify, to tell me, yes, they are inverses, you do both compositions, okay? Because if you look down here at the bottom of the line, it says these guys are inverses if and only if f of g of x is x and g of f of x is x. So you have to check both compositions, simplify down, and see if you get x. That's the only way you can tell if 2 functions are inverses of one another, for sure, to be 100% with it. Determine whether each pair of functions are inverse functions. F of x equals 3x plus 9, g of x equals 1/3 x minus 3. You go find both compositions. Okay, you do f of g of x, and you do g of f of x. And both times, if they're going to be inverses, they have to equal just x. So they have to simplify. When you're done simplifying everything, you got to be left with x. Not 2x, not a half x, not x squared. X. Both times. Okay? So the first one, we're going to take f of what g of x is, which is 1/3 x minus 3, and plug it into f. It's going to give us 3 times 1/3 x minus 3, and then the plus 9 afterwards. Distribute the 3. So you get 3/3, which is x. 3 times -3 gives you -9 plus 9. And then that simplifies down to just x, just like that. Okay? So you're looking good. Okay, you're looking good, but you have to still go check the other one. Okay? It's a rare case. It's a rare case, but sometimes the first one will give you x and the second one won't. Okay, so you do have to go check the second one. All right, just because the first one gives you out what you want doesn't mean the second one will. Okay, Ron?
On the test, would you make us do both?
Yes. Yeah, you would have to. Okay. So the second one, we're going to do g of what f of x is, which is 3x plus 9. Okay, going down here, plugging it in. So you do 1/3 3x plus 9 minus 3. Distribute the 1/3 through. So 1/3 times 3 gives you x. 1/3 times 9 gives you 3 minus 3. X plus 3 minus 3 gives you x. So are these two inverses?
Yes.
You say yes. Yep. Plug in 1/3 x plus 4 into f. That's what g equals. Distribute to 3. Cancel the x. So you still get x. That's a plus. The problem is 3 times 4 is 12, and 12 minus 3 is 9. So you get x plus 9. And that's not what? That's not x. So are these two functions inverses? No. And if that's the case, if the first one doesn't work, you are done. Because there's no point in doing the second one. Because even if it does work, the first one doesn't. And they both have to be x. Okay? Chamberlain.
Look at the, you plug in the 3x minus 3.
I plug the 1/3 x plus 4 into the 3x minus 3. G into f. See, g's inside f. So take g, put it into f. Okay? Anybody else? Okay, we're going to skip the last one, I think. Yeah, skip that one. Your book assignment's this, page 396. 15 through 20, 27 through 32.